Good morning, afternoon, or night, whenever you're watching this. This is statistics, topic, mean, median, mode, range, and IQR. The following is your vocabulary: mean, median, mode, range, and IQR. Please write this down as you will need to know what all these words mean. And here we go. The mean is the sum of the values in a set divided by the number of values in the set of numbers. The median is the middle value of the set of numbers when the values are arranged in order from least to greatest. The mode is the number the most repeated in the set of numbers. The range is the largest number in the data set minus the smallest number in the set. Interquartile range in the data set is the difference between the third and the first quartile. Now that's a lot of information to throw at you guys. Just remember, for the most part, that you're going to see these values over and over. And these are not words that are going to go away. So you guys will know what all these are, and we're going to just have to work through them, right? If you're wondering what a data set is, because I've used that word a lot, let's see. Data set is usually denoted by these squiggly little lines or these parentheses, right? I'm going to use parentheses because it's easier to use parentheses when typing things out. But generally speaking, we have these little lines, right? A data set is just number of data. It's numbers inside of a data set. Like this. This would be an example of a data set. And a data set can include any number of numbers. There's also a distinction that you need to be aware of. Whenever we're calculating mean, or whenever I say number of numbers, for example, right? Whenever I say number of numbers, right? What I'm really saying is I want you to count how many numbers are in the data set. So for example, the 0 counts as a number. So 1, 2, 3, 4, 5, 6, 7, and 8. There's a total, right, of 8 numbers in this data set. And remember, this whole thing is considered my data set. Whatever's inside of those little brackets, all right, that's my data set. The 0 makes a big difference inside of a data set, and it's going to make a difference when we're talking about means specifically, when we're talking about this one, okay? 0 in this case is considered a number. It is taking up a spot in the data set, and it will make a difference in the calculation, even though 0 is considered to be nothing. It will change the value of your mean at the end of the day if it is included in your data set. So just keep that in mind. Median is different from mean, and we're going to see the difference in a bit. But just know that median is just, it sounds like the word middle. And that's because that's where it's derived from. It's specifically referring to the number that's at the center of this data set, right? There's always a number in the center, even if there's an even number of numbers. Like for example, here there's 8, right? And if there's 8, there's going to be 2 numbers that are kind of fighting for the center, right? There's a way we can just take the average of, we can just take the mean of that number, and we have our ultimate median. Again, I'm getting too deep into this. Why don't we focus more on just what is mean, right? How to calculate it, and what do you do, okay? So when I say mean, I'm just referring to something else. There's another word, right? The word is average. So whenever you see here in math, someone say, find the average, they're asking you to find the mean, right? The mean of a set of numbers. In general, in the real world, when people use the phrase, things like on average, how many hours a week do you watch TV? They're just asking you to kind of guess how many hours you normally watch TV. The key word here is normally. Average is kind of saying like normally or usually, or it's referring to that in the real world. In statistics class, it's going to refer to a specific number, the number that's within the center of the data set, numerically speaking. And there's a difference between the number in the center of the data set, numerically speaking, and the number that's physically in the middle, which is the median, which is the next thing we're going to do. All right, there is a difference. For now, what do we do? Well, the problem you're going to see this week usually is going to be talking about this problem. Find the mean of the data set. Data set is given right here. Our data set is 0, 1, 2, 3, 4, 5, and 6. Here are the steps that you're going to have to take. Right? Make sure you're writing all this stuff down in your notes because you're going to need to turn in your notes for points. Right? Step 1, arrange the data set from least to greatest. Step 2, add all the numbers in the data set to get a single number. Step 3, divide the sum of the numbers from the previous step by the total number of numbers in the data set. Step 4, round your answer to the second decimal point or the nearest whole number if necessary. Okay, now why don't I go ahead and do this so you can see the way it looks like. For starters, step 1, right, it's asking us to arrange our data set in order from least to greatest. Luckily, that's already been done for me. The data set that was given to me was already in the form of least to greatest, so I didn't really have to do anything, right? This was already there. Okay, cool. I've done step 1. Step 1, check. Okay, now step 2, add all the numbers in the data set to get one single number. Okay, then let's start with this. 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, so what that all totals up to, if you put it on the calculator or you just add it up in your head, right, we end up with 21, right? And that's the sum. This is considered the sum, right, of the numbers in my data set. Again, sum just means that it's the answer to a bunch of numbers that have been added together, right? That's all it means. So, okay, cool. I'm done with step 2. What about step 3? Divide the sum of the numbers from the previous step. Okay, so I'm going to divide 21 by the total number of numbers in the data set. Okay, there's that whole number of numbers, right? Number of numbers, right? We see that phrase again. So again, I have to count how many numbers there are in my data set. And as I've said before, 1, 2, 3, 4, 5, 6, 7. There's a total of 7 numbers, right? This is the total number of numbers in my data set. And I know that I have to divide the 21, which is what I got first, divided by the number of numbers, which is 7. So I'm going to go ahead and do that in the form of a fraction, 21 over 7, right? Now, the 21 is, I don't know where you guys are in terms of your math, how long it's been since you've done algebra or anything like that. So I'm just going to explain it as if you don't know, okay? So if you do know, good. If you don't, just pay attention. 21 in a fraction is considered your numerator. I'm going to put an N. 7 is considered your denominator. I'm going to put a D. These are something that you should just know from before, right? If these words do not sound familiar, don't worry. I'm going to use the words a lot, so it's not the last time you'll hear them. Right? What this is saying is 21 is being divided by 7. It's being broken up. 21 is being broken up into 7. Is being divided up into 7 pieces, right? So how many do you get after that? Well, if you're using a calculator, make sure to put 21 first, then do the division, then divide it by 7. 21 divided by 7 is just 3, right? Lucky for me, my answer is a whole number. I don't need to round, right? I'm done with step 3. Right? I'm done with step 3. Step 4 says round your answer to the second decimal point or to the nearest whole number if necessary. Okay, so my final answer is 3 right now. I have the answer. Right here where it says problem, find the mean of the data set. Well, my mean equals 3, or M is equal to 3. I would accept either answer, right, when you're doing your problems. But just know for step 4 is kind of optional. Whenever I say round, it's a little bit optional. Since this is already a whole number, I don't need to round. If you're wondering what rounding is, It's a way of eliminating excessive numbers. So for example, let's pretend that our number was 22/7. And this gives me a really long decimal point. It gives me 3.14, and it kind of goes on for a long time after that, right? Now, here's what I mean by round to second decimal point, right? Because there's rules for rounding. Again, if you don't know how to round, just pay attention. If not, feel free to fast forward past this part, right? So let's see. The full number that my calculator gives me is 3.142857 142, and technically this is theorized to go on forever because if you don't know, 22 divided by 7 is pi, and pi is something else. But just so you know, I don't want to write all these decimals down, and I don't expect you to write them all down. However, if you do get a decimal that repeats like this, what I want you to do is I want you to round to the second decimal point. You go to the second decimal point's right here. You're gonna go 1, 2, you're gonna stop here. This is your focus. Once you're there at the second decimal point, the second decimal point is gonna look to the number to the right of it. And if the number to the right of the second decimal is if it is a 4 or lower, and if it is a 5 or higher, there are different rules. So if it is a 4 or lower, like in this case it's a 2, which means 2 is less than 4, I'm gonna just round to 0. And if it's a 5 or higher, the number to the left, that 4, gets a +1. Okay, so in this case, this would be rounded off to just 3.14, and the rest of them become 0, so I don't have to even do anything. But I'm gonna go up here now because there's space up here. If, right, we have a scenario where we have 3.147 or something that's bigger, right? This is the number that we're focusing on. Since this is 5 or greater, it's gonna add 1 to that, and the rest are going to become 0 after, which means I would round to 3.15 at that point. Okay, that's just rounding. Okay, remember, as far as mean is concerned, our answer is just 3 for this problem. Our mean is 3. That's it. Right? We didn't have to round. We didn't have to do anything else. But if we had to round, this is what we would do. Okay. I also say round to the nearest whole number if necessary. What I mean by that is in the real world, we can't always rounding is necessary. Like for example, if when I'm talking about people, for example, if these were the number of people in a group or something, I can't have a part of a person be a part of a group, right? If my answer is 3.14, I'm just gonna say, well, we're gonna have 3 people in a group. I round down to 3, right? Because I can't have part of a person. But if we're talking about splitting up like a pizza or something like that, I can definitely have part of a slice of a pizza, and 3.14 would be appropriate then. So it just depends on what you're talking about in the real world. Okay, that's what I mean. You're gonna just in word problems, and they're asking you if they tell you they want one thing or another, do that. If they don't, use your best judgment. I will accept either answer. All right, moving on. How to calculate median and mode. Median is the number physically in the middle of the data set. An odd number of numbers in a data set will always have a number in the middle. However, an even number of numbers in the data set will require you to take the average of the 2 numbers in the middle. Now there's that word again, there's average. So you might have to do what you just learned in the previous slide in this problem. Maybe, it depends. Mode, on the other hand, right, something different. Mode is just the number that's repeated the most in the data set. You can have multiple modes, okay? Mode is much simpler than median, so we're gonna focus on median first, right? We're gonna move on here to where it says problem. Problem, find the median and the mode of the data set, and they give you the data set, right? In this case, if you notice, we're gonna use the same data set for all these problems just so you can see the difference, right? But Yeah, so it's same data set that we've been working on. We move on to steps for finding it. The first step is to arrange your data set from least to greatest. Well, lucky for me, that's already been done for me. And if you follow the arrow, right, we're over here. This data set has already been arranged. It's 0, 1, 2, 3, 4, 5, and 6. It's in order from least to greatest. Good. Okay, we can move on to step 2 now. Step 2, locate the number physically in the middle. If there's two numbers, take the average. Now in this data set, I have 7 numbers, which means it's an odd number because 7 is odd. That means that there's going to be one number right in the middle. And there's going to be, in this case, 3 numbers to the left of that, and there's going to be 3 numbers to the right of that. That's how I know it's physically in the middle, right? There's an even number of numbers to its right, and there's the same number of numbers to its left, right? And the 3 is just kind of, well, in the middle. If this is indeed my data set, right? My mean, I already figured it out. My median, sorry, I keep saying mean. My median is just 3. Hey, isn't that kind of like what my mean was in the last slide? Well, it is. But if you notice, I have step 3 where it says round if necessary. Again, the same rule applies that I said earlier. If the numbers in your data set are not like whole numbers, if you have decimals in your data set because you're dealing with money, right, and cents, then yeah, you're gonna want to round, or maybe you don't want to round. It just depends on the context, right? It's best for you to round though. What I have here though, right? If you notice, I have another data set right here, and we're gonna talk about what it means when you don't have an odd number. This is the easy version of the problem. But what happens if I didn't have that 0? This 0 right here. What happens if I remove that 0 and I have an even number of numbers? Instead of having 7 numbers in the data set, without 0, I now have 6 numbers in the data set. 1, 2, 3, 4, 5, and 6. Right? This 6 is an even number of numbers in the data set, which means that there's 2 numbers that are fighting for the middle, right? This 3 and 4, right? So which one is my median? I can only have one median. Well, the truth is that the actual number is somewhere in between 3 and 4. And the only way to figure it out is to take the average. Now, taking the average just means to find the mean between 3 and 4. This time, we're only focused on 3 and 4. We're going to add those 2 numbers up. If you remember from the last slide, we're going to add up those numbers. The only 2 numbers I'm going to add up is 3 and 4. And since there's only 2 numbers that I'm adding up, I'm only going to divide by 2. So now we have a situation where we have 7 divided by 2, which is 3.5. In this case, if you notice, I drew a line in between 3 and 4 because 3.5 is going to be directly in the middle of 3 and 4, right? It's not always going to be this easy. Sometimes, especially you have decimals, they'll be much more difficult to find the center. You are going to have to add weird numbers up and divide them by the number of numbers. So just be aware that this is something, when I say like take the average, this is what I want you to do. And you're going to do that more in the next slide too. Okay, cool. So I hope you're good with median, right? This is all separate. We're going to move on to mode now, right? Okay, so for mode, again, there's only 2 steps really, and there's 2 things to consider, right? Okay, what is going on here? Sorry guys, my computer is acting up for a second. Okay, there it goes. So step 1, find the number of numbers in the data set which repeat, right? So in this case, my data set, the one that you're used to, is this one down here, is this first one. Now, if you notice, they're all in order from least to greatest, yes. But then I move on to step 2. The number which repeats the most is your mode. But I have a problem. None of the numbers repeat, like at all. They all show up in the data set once. The 0 shows up once, the 1 shows up once, the 2, and it goes on, right? In this case, your answer, when I'm asking what is the mode, is to just write no mode. There's no mode because none of the numbers repeat. Okay, cool, I'm done, right? Well, yes, but there's also two other scenarios to consider. The one in the middle that I have here is a different data set. We have 0, 0, 1, 1, 2, 2, 3, and 4. In this case, it's the first note, right? The first note was the first problem when there's no mode. The second note is the one that I have here. If multiple numbers repeat equal amount of times, each one is the mode. Sorry, I miswrote that. So here, since the 0 repeats twice, and the 1 repeats twice, and the 2 repeats twice, all three of them are in a kind of three-way tie. Therefore, all three of them are your modes. You are allowed to have multiple modes. In this case, you'd write mode is 0, 1, and 2. 3 and 4 don't repeat, so they have nothing to do with mode. Okay. What you're more likely to encounter, though, in most of the problems, these are just like exceptions to the rules, right? What you have here, however, is what you are expected to find. You'll have a data set that'll have like 1, 2, 2, 2, 2, and then 3, 3. Now, if you notice 3 repeats, right? There's two threes, and the number 2 repeats about 4 times. So both 3 and 2 repeat, but both of them are not your modes. The 2 is your only mode in this case, because when we are dealing with mode, we only want the number that repeats the most often. The only time we include more than one mode is if there's a tie between different numbers. Okay, so mode should be the easiest thing of this whole problem. If you have problems with it, please just let me know. Okay, we're gonna move on. Range and interquartile range. Okay, so we're almost done, guys. Just bear with me. Range is just the largest number in the data set minus the smallest number in the data set. Interquartile range, however, is basically the same thing, except we have to deal with something called quartiles. Right? It's just the largest quartile minus the smallest quartile. In other words, it's quartile 3 minus quartile 1. Right? In case you don't know or you haven't been paying attention, we're right here. Okay, so why don't we just jump into a problem, because I feel like the best way to deal with range and interquartile range is just to like do a problem. So the problem is to find the range and the IQR of the data set. IQR is just interquartile range. Okay, so we have to do that with both. The steps to find the range, step 1, identify the largest and the smallest number. Well, in here, the largest is just the biggest number, which is 6, positive 6. The smallest is 0, right? So if we wanted to find the range, we just have to subtract them. So we subtract 6 minus 0, and we get 6. Our range equals 6. Okay, cool. It says round if necessary. Again, that step is more optional than anything else. It's just letting you know that if I had like 6.5 or something, I can always round my answer to 7, or stuff like that. Unless I ask you specifically not to round, you can just leave it. In this case, this is a whole number and we don't need it. Okay, cool. So range seems fine, right? What about IQR? What about interquartile range? Well, step 1, it's a little bit more complicated, but arrange the data set from least to greatest. Okay, cool. Let's do that. It's already been arranged for me. 1, 2, 3, 4, 5, 6. Okay, this is my data set. I've arranged it. Find the mean of the data set. That becomes my Q2, my quartile 2. Okay, so I know I said mean. Sorry, I meant median. I wrote median. Okay, find the median of the data set. Remember in the previous slides, I said if we want to find the median, it's the number that's physically in the middle. In this case, I have 7 numbers. So there really is just going to be one number in the middle. 3 is my median, right? My median is 3. That is what we call my Q2 because it's right in the middle. My Q2 is also 3. That is my Q2. I found it really easy because this data set has 7 numbers in it, and 7 is an odd number, and I know there's going to be a number inside of that. Now, there's 3 numbers to the right of this. There's 3 numbers to the left of this. So that's how I know that it really is the median. All right, there's an even number of numbers on the to the left and to the right of it. Okay, cool. So I've done step 1. I've done step 2. Is there anything else? Step 3. Find quartile 1 by looking at the number to the left of quartile 2. Find the median of the numbers to the left of quartile 2, and that becomes quartile 1. Okay, so now we're going to ignore the 3, and we're going to ignore everything to the right of the 3. So right now, I'm only focusing on this 0, 1, 2, right? This is my quote-unquote left of Q2, right? There's only these 3 numbers to the left of Q2. I need to find the number in the middle. In this case, since there's only 3 numbers, it's really easy. It's just 1. My Q1 is 1. Okay, that was easy, right? Right here. This is my Q1. Okay, cool. Now we can move on to the next one, right? I can find to step 4. I did step 3. Step 4, find the quartile by looking at the numbers to the right of Q2. Okay, so let's look at the numbers to the right. We have 4, 5, and 6. These are the numbers to the right of Q2. This is why Q2 is so important, because we're going to use it to find the other 2. Now, 4, 5, and 6, right? The number in the middle is 5. My Q3 is 5. Okay, then. Now we can move on to step 5. Now that you know what Q1, Q2, and Q3 are, subtract Q3 from Q1 to get your IQR. Our final answer is just basically a Q3 minus Q1, which is just 5, because we found out our Q3 was 5, minus 1. So IQR equals Q3 minus Q1, which gives me just 4. My IQR is 4. Well, as usual, this is the basics of it, right? But there are harder versions of IQR. And the harder version is what happens if it's not an odd number of numbers? What happens if it's an even number of numbers and we have to take the average and all that? What do I do? Well, I'll show you. Okay, so we're going to extend that example, but this time we're going to include our, let's see, we're going to exclude our good friend 0. We're just going to have 1, 2, 3, 4, 5, and 6. That's right, we only have a total of 6 number of numbers in our data set, and our goal is to find range and IQR. That's what the problem is saying. Well, range is easy enough, right? Range, I'm just going to take the biggest number, which is 6, and I subtract it from 1. This time, since my smallest number is 1, my answer changes from the previous problem, right? Instead of it being 6, my range is now 5. Okay, cool. That's done, right? Check that off. What about IQR? Well, it's a little different. We still have to find the mean. We still have to find the median, right? This time, however, the median is stuck in between these two, because now our median is going to be in between, right? So we take the average. By taking the average, we take 3 plus 4, and we're going to divide it by the number of numbers that I'm adding, which is 2. We end up with 7 divided by 2, which equals 3.5. Okay, cool. So I have this. I have my Q2, which is equal to 3.5, right? I'm good, right? Well, yes and no. Something you have to keep in mind is that 3 and 4 are technically still part of the data set, okay? And this is where it gets real tricky, but 3.5 doesn't actually exist in the data set, right? So although we know our Q2 is definitely 3.5, 3.5 is not an actual number in the real data set. In the original data set, it doesn't exist, meaning that if we want to find Q1 and Q3, we're gonna do the same thing that we did in the last problem. We're just gonna have to take something into consideration, right? This line that I'm drawing in here is a reminder that our Q2 is in between 3 and 4, which means that I haven't neither 3 nor 4 are part of my Q2. They're not. Which means that when I'm looking for my Q1, I'm looking at all the numbers to the left of my Q2. That includes 3, which means that I have, sorry, let's undo that. Let's undo that too. I have 1, 2, and 3 to the left of my Q2. This is to find my Q1. Hey, look at that. There's a number right directly in the center, right? So this means that my Q1 is 2. Okay, so what about to the right? What about if I want to find out Q3? We have 4, 5, and 6, with 5 being in the middle, right? So we have our Q3 is 5. Well, okay. Well, what I don't want you guys to do is I don't want you thinking that 3 and 4 are part of Q2 and you're not counting them and you're like, well, 5 and 6 are there. I have to take the average of that. No, you don't. It can be tricky, but just remember that 3 is part of the left-hand side, 4 is part of the right-hand side, and Q2 actually exists right in between. There's no actual number for it, but it's technically there. Yeah, slight difference in interpretation. Okay, so how do we finish this up? Well, we take Q3, we subtract from Q1, right? And this time we have 5 minus 2, which gives us our answer. Our IQR for this data set is actually 3. Our range is 5, and that's different from the previous one. Now notice in the previous slide, we have our interquartile range was 4, right? And our range was 6. So that 0, even though 0 represents nothing, by having it in the data set, it is counted as a whole number. And it technically makes a huge difference. All right. Okay, then. So that was a lot. Expect one of these videos a week explaining the stuff that you're going to do. Every day I'm going to post something, although this week I'm going to post everything all at once. Due dates, I'm going to put all the due dates up. There's going to be a sheet. Make sure to read it. I'm going to announce when the due dates are. But basically, every day I'm going to post a question, a warm-up question, and it'll be questions that you can find the answers in the videos. Then I'm going to post work for that day, right? As far as the notes are concerned, you just have to write your notes, all the notes that you wrote for this, take a picture of it, upload it for points, okay? That's the first thing you should always do at the beginning of every week in my class. Watch the video first. First thing you do, watch the video, write down all your notes, take a picture of your notes, upload your notes as your first assignment. You'll have a warm-up question to do after that's due that day, and then you'll have a worksheet that's due by the end of the week. This is going to happen for 4 days, Monday, Tuesday, Wednesday, Thursday. Although there's only one video a week, you'll have a warm-up and an assignment every single day, okay? We only have 5 weeks, guys, and we're going to have to do this. It's gonna take a while, right? I just wanted to let you guys know that, right? There is one last thing we got to do before I let you guys go. Sorry about this, right? I just had to include that because most people zone out before I say this. But word problems. Okay, so all these skills should be easy enough for you guys to do. Most students don't have too many problems. Once they get the hang of it, they're good. Where most students struggle here is word problems, right? So what I'm gonna do is I'm gonna give you an example of a word problem. that you could run into, right? And then we're gonna quickly do this right now, because a word problem like this, you can totally do it with everything I've just shown you, right? But you'll see that it requires a little bit of algebraic thinking, right? Okay, so to earn an exemption from the final exam, whoops, Aaron needs his mean test score, to be 95 or greater. If Aaron scored 93, 99, 90, 93 on his first 4 exams, and still needs to take one more test, what is the longest, I'm sorry, what is the lowest possible score he can get on his last test to maintain a mean test score of 95? Okay, the reason why I wanted to type this out in the way that I showed you, and I didn't just have it typed out, is because I wanted you to read the problem very slowly. Like most of the times when we're doing these word problems, most students tend to skip important information, right? My hope is that by watching me type it out, you noticed a couple things, right? And here's a couple things that you should notice, right? Whenever you're doing this, information in here matters, right? So what he's saying is we want our mean to be 95. We want this, right? Because it turns out Aaron can skip his final exam. He doesn't have to take his final. If his other test scores on average of 95 or greater, right? So far we have the data set. The data set is 93, because that was his first test. 99 was his second test. 90 was his third test, and 93 was the last test. This is his current data set, right? He still needs to take one more test, okay? And this is where it gets tricky. He still needs to take one more test, which means that there is an unknown score. I'm going to put the unknown score to be represented by X, right? We need to find out what is the lowest possible score that X can be so that his mean can stay 95 or greater, so that he doesn't have to take his final exam. He goes and he asks the teacher, hey, teacher, what do I need to get on this next test in order for me to not take the final? And then the teacher's like, okay, well, interesting. Let me figure this out for you, right? And then he's like, or better yet, why don't you figure it out? You have your previous test scores, set up the problem. What you're going to want to do here is, we know the answer, right? Our mean is the sum of the data set divided, right? This is a fraction, by the number of numbers. Okay, so with that said, right, we know what our mean is. Our mean should be 95 or greater. Well, let's just stick with 95 because he wants to know the least amount. The sum of the data set would be 93 plus 99 plus 90 plus 93 plus X in this case, right? And we're going to divide by the number of numbers. In this case, it's just 5 because there's 5 tests. Okay, so far I've plugged in what I know, right? And this is me applying what I know, right? How do I solve this problem? Well, we're gonna have to use some algebraic skills that you may or may not have. Now, in this case, well, I'm gonna wanna add, right? I'm gonna just wanna add up all the numbers, right? So if I were to add up all the numbers, I end up getting 375 plus x divided by 5. Okay, so I added up all the numbers. I don't know how to deal with this x. What do? Well, at this point, I want you to see the numbers as separate. 375 is being divided by 5, but x is also being divided by 5, which means I want you to separate these. If you're not good with fractions, it's okay, right? I'm just doing this. I'm separating this to show you that this is the same as this. I just separated it is all I did because I want you to know what to do next, right? You can't divide x by 5 because I don't know what x is. So I'm going to separate it out, right? Make it into its own fraction. And I'm going to divide what I do know, 375 by 5, right? So at this point, I can just divide 375 by 5. So let me go ahead and do that really fast on my calculator. Okay, so 375 divided by 5 is 75. So I have 95 is equal to 75 plus x over 5. Okay, so at this point, what do? Well, I have to do what's called isolating the x. I have to subtract 75 from both sides, and I end up with, well, that becomes a 0, and this becomes a 20, x divided by 5, right? X divided by 5 is equal to 20. Well, that doesn't tell me anything. That means that I have to get rid of the 5, right? And since the x and the 5 are dividing, I have to do the opposite of division. I have to multiply. Well, what am I going to do? I'm going to multiply 5. And if I multiply 5 on the left side of the equation, on the right side of the equation, sorry, I have to multiply it on the other side to make sure it stays balanced. 20 times 5 is 100. This cancels out, and I'm left with x is equal to 100. The answer is that this person needs to get 100. The only score they can possibly get, they have to get a perfect score on their final test in order to maintain an average of 95 so that they don't have to take their final. If they, maintain this average, if they get a perfect score, they don't need to take their final. Now, if this way that I did this seems a little complicated, I'm going to redo this problem, right, with a slight exception because I'm going to explain this section right here in case you don't know what happened, right? So let's see, I had, what was it, 95, right? Is equal to 375 plus x divided by 5, right? If you don't like the last method I did, you can do something else. You can do it this way, and hopefully this makes a little bit more sense. The idea here is when we have an equation like this, we want to get rid of all the numbers. We want to make sure x is by itself. So we can say one x of something is equal to one number, right? The easiest way is to get rid of the fraction because the fraction is making our lives miserable, right? And as I said earlier, since the fraction is division, I do the opposite. I'm going to multiply by 5 over 1, another fraction. I'm going to multiply the other side by 5 over 1, kind of like what I did earlier. The reason why this works is because if I multiply 375 plus x over 5 times 5 over 1, what ends up happening is I have the same number. I have 5 on top and I have 5 on the bottom, which means that they can cancel out. And then I end up with 375 plus x over 1. But anything over 1 is just itself. So really, I can kind of ignore that. And I end up with 375 plus x. The fraction has been eliminated. But when I multiply on both sides, if I multiply this right-hand side by 5, I have to do the same thing to the other side because if the 375 plus x are being multiplied by 5, the 95 also has to be multiplied by 5 to keep up with it, to stay balanced, right? So 95 times 5, right, would just be 475. Hey, look at that, right? 475 is equal to 375 plus x. So what do I do now? I still have to isolate the x. The x is still has to be by itself. Since it's adding, I subtract 375 so I can leave x by itself. I had to subtract it from both sides. This cancels out, and I'm left with 100 is equal to x, just like I was left with in the other problem. You can do it this way. I actually prefer this method. The book prefers what I did here. I don't care which method you use as long as you can understand how to do it, okay? Don't worry if you don't understand this method, right? Word problems are the hardest thing for everyone to understand. So that's it for this video. I know it was kind of long, but be prepared for a long video every week, and you only have one per week. So good luck. And once again, oh, by the way, if you're having trouble, you can always communicate with me through this email. So that's an S. dpalacios@laedcorps.org. You can always send me an email, say who you are, I'm a student in your class, I need help with whatever, and then we'll set up a Zoom appointment time so I can talk to you one-on-one. Or if it's a quick question, I'll just email you an explanation or a clarification. All right. Good luck, guys. See you next week.